Do you know the advantage of JK flip-flop over the SR flip-flop? So let's get deeper dive into how the JK flip-flop works and what are the disadvantages that it has and what are the merits that it has comparing to SR flip-flop. So first thing, let me build the circuit how the JK flip-flop is built. So here everything which is taken from the previous thing. So previously SR flip-flop was taken from SR latch. So similar to that now JK flip-flop taken over SR flip-flop. So here, so this is an SR flip-flop. So where there will be Q, Q naught. So two output is there, right? So this is similar to that. Just extra what we are adding is that, so here clock is also the same. So here everything is same. So here we will be adding an AND gate. So to AND gate, the one output is K, one output is J. The next output which is connected to the toggled inverse version. So let me complete this one. Okay, so one output is taken from here and that is connected over here. So this is one thing. So another one output similar to that, that is taken from here and that is connected to the above input. So thing here is this. Okay. So this one is J and another one input is K and this is the clock. This is directly given to the S input and this is directly given to the R input. So here the one disadvantage that we have is that there is one invalid state that was present in the SR flip-flop. So let's see how that is broken here. So here, so if we take the condition, the clock, let me first start with the truth table. So whatever may be the thing in the sequential circuit, everything is based on truth table only. So where in a combinational or Boolean algebra K map is right. So similar to that, everything here is a this one truth table and JK characteristic flip flop and excitation table. So 0, whatever may be the X output, then output will be no change. That is as it is. So when clock is 1, so we are giving 0, 0 as input. Okay. So when J is 0 and K is 0, then the SR flip-flop's value will also be 0. So when J is 0 and K is 0, so this value will also be 0. So this will also be 0. So whenever we are giving 0, 0 to SR flip-flop, what will happen? The state will remain same. So then the state will be remaining as it is, that is Qn. Okay. So then another states which is nothing but 0, 1, 1, 0, sorry 0, 1, 1, 0, 1, 1. The clock is 1, 1, 1. Okay. So let's see how the changes are stating here. So here is 0 and 1. So, okay, so let me use the blue color pen. So if we are giving j which is equal to 0 and k which is equal to 1, so here the s value will be 1, but here the k value that is depending on the previous one's output. Okay, for an example, here if the previous value is 0 and 1, so for an example if it is 0 and 1, so here this 0 will come as it is. So here this 0 will come as it is. So 0. So here also 0. So here there will be change that this will be 0 and here this will also be 0. So if it is previous k, it is 0. Then what will happen? Output also remains 0. Okay. So this is one case. So if we give j which is equal to 0, k is equal to 1, so the thing will happen like this one. So because initially that was 0 and 1, so that is maintained to 0. So if the condition which is 1 and which is 0, then what will happen? So this is already 0. So it will come as a 0. So 0 into anything, that will be again 0. So this change, the state will be same. So whenever you are giving 0, 1 as the input, output change will be set to 1. Sorry, 0. That will be reset to 1. So when we are giving 1 and 0, so j which is equal to 1 and k which is equal to 0. Okay. So 1. So here it is 0, right? So whatever may be the input, the output will here will be 0. Okay. So based on the previous value, it will be there. So for an example, if the previous value is 0, so here it will be 1. So 1 will be configured here. So 1 into 1, so the value will be coming 1. So 1 0 when we giving, the output will be changed to 1. Okay, so that is the same. So the simple, when we give 1 and 1, the output will be toggle. So that will be Qn. So this will be toggle condition. So previous state will be toggled. Okay. So this is what the truth table for the JK flip flop. Here we can clearly see that the invalid condition is removed. Okay. So that is what the thing that we are taking into consideration. So the characteristic equation, what will come here is that if we do the truth table and find it. So let me go to the new table and let me draw the characteristic curve. You guys know, right, how to draw the characteristic curve. So that is just an extension version. So JK Qn plus 1. Okay, so 0 0 0 0. So whenever the value is 0 0, the previous state will be maintained as it is. So the thing is that if it is 0, it will be 0. It will be 1, output will be 1. So 0 1 0 1. So whenever the value is 0 1, the output will be set to 0 always. So even if it is 0 or 1, output will be always set to 0. So here 1 0 1 0. So 1 0 is the case, output will be always set to 1. So even if it is 0 or 1, output will be always set to 1. So if output is 1 1, then the output will be toggle. So if it is 0, it will change to 1. If it is 1, then output will be changed to 0. Okay, so this is what the characteristic equation curve that we have. So let me draw the K-map. So you guys can also pause the video here and try to complete the K-map. So this will be practice for you guys. I'm suggesting all to try. And if you guys able to get the answer, please post in the same in the comment section. So this is simple. So just the truth table to the K-map mapping. So if you do is, then here J, K, Q, N. So this K map is for Q n plus 1 finding. So it is 0 0 0 0 0 1 1 1 1 0, right? So it will be 1 1 1 1, right? 4 ones are mapped. So how this can be mapped is this. So it can be mapped like this one, right? Okay. So if we write the Q n plus 1 equation, then what will be equal to? So this one, if we take this one, so this one is a J bar and this one is Qn, J bar, sorry, JQn. This is 1, right? So I made a mistake. So this is 1. So this is 1. So which is J Qn bar plus K bar Qn. Okay. So this is a characteristic equation. So excitation table, how the excitation table will come is that the simple where we be taking the key parameters, right? How the state of transition is happening. So Qn plus 1 Jk. So 0 0 0 1 1 0 1 1. If it is 0 and next state is 0, then possibilities for a thing. So 0 0 0 0. So there is a 2 case, right? So 0 0 0 0. Then what is the state? J is always 0, but K can be X. Okay. So let me take a red pen. So if it is changing from 0 to 1, so what are the case we are changing to 0 to 1? So 0 to 1 is changing to state where J is 1 fixed and X can be varied. Okay. So that is what the thing. So let me take loop line for a third one. So 1 to 0. So 1 to 0 here, then 1 to 0 here. So if we think the case, the K is fixed 1 and this one is X. Okay. Then the last state is that is 1 to 1. So 1 to 1 is both the change are stating. So we can directly write it X and 0. So J is 0, right? So here if you see here also same order. This one you remember 0 1 XX and reverse it. So this comes as ulta the 0 1 1 0 XX. Okay. So I hope you guys able to understand the functionality of JK flip flop, right? So here the thing is that all the disadvantages are removed and everything is done. So switching times of flip flop. So that is one important term that we can discuss. So setup time. It is a minimum time for which the input must be maintained before the clock so that the output will be changed. So that is the thing. So something the setup time. So let me just to say the things. These are not that much important, but will be helpful if you guys know these things. So setup time. So setup time is the parameter which is the minimum time of thing where we need to minimum time for which the input must be maintained constant before applying a clock. I hope you guys able to get it right. So hold time. So next one is the hold time. Okay, so hold time is another one concept where what will happen is that it is a maintained time for which input must be maintained. So hold time, so which is the it is the minimum time for which input must be maintained constant before clock change. So that is the minimum time for which input must be maintained constant. So this is also similar to the where the input must be claimed in where the setup time is after. The setup time is before, this is after. So this is before clock pulse. So before CLK, this is after CLK. So all the time is the after the output change we need to maintain the clock pulse. So there is propagation delay, the concept is there. So that is similar to what we discussed in the thing. So race condition is also there. So race condition is one of the very important term. So let me briefly explain this one. So let's take a clock pulse. Okay. So clock is at 0, then that is immediately changing to one state. So this is one clock. Then it is again going down. Then again it's going to one set of round. Then it's again going to. So the repeated, as you know, right, how clock works. Okay. So this is nothing but a clock. So here is a Q, the state in Q, which is changing repeatedly even for a single change in output. So this condition only we state that as a race condition. So there we discussed, right, hazards. So hazards there is will be only one change, but here the output will be toggled repeatedly. So this is the condition where we consider as a race condition. So there is some condition in order to make this race condition to exist. So let's discuss what are the conditions that it need to be there in order to trigger the race condition. So then it will be normal because when a clock is going into lower state, there will be no changes. Okay. So this is case 1. So this is clock. So when j and k which is equal to 1. Okay. So why we are taking this condition is that when j and k both are 0, both are 1. So there is a condition that the output will toggle independently. Independently means there will be multiple toggling will happen. So that is what the thing. So if we take the example that the j and k which is equal to 1 and 1, then the output will change. The output not every time it will change as it is. So there will be some condition for this to exist. So let me take the condition that j is equal to k which is equal to 1. So this is the case, right? So the qn plus 1 will be depending on the characteristic equation. The characteristic equation is what? So which is j qn bar plus k bar qn. Okay. So if we apply this condition, so let's here take the previous condition as it is q. So if it is j is equal to 1, so this is qn bar plus k bar which is 0. Okay. So here if you see, if when both the input are high, then here if you see the q, if the q is maintained like this, so the q, the next qn bar 1 flip because that is a 0. So then what will take on the previous state, this is q. Okay, this is q. So first it will, what will thought is that, so initially it was 0. So when j and k is 1, it is changing to j and k is equal to 1, it is changing to 1. So then j and k is also 1. So then what it will stay, it will need to toggle because it is in one state, so it will toggle to 0. Then again 0 to 1, then 1 to 0, 0 to 1, 1 to 0, 0 to 1. Then only when j and k which is equal to when the clock is going to down state, then only this toggling will stop. Okay, so this is the condition where for single change in the input, the output is changing multiple times. So this is not expected, right? So this condition is called RAS condition. So there is some criteria in order to for the existence of clock, existence of RAS condition, and also to avoid the RAS condition. So the thing is that the T clock, whenever the T clock is much greater than the propagation delay, which is TPD. So propagation delay is nothing but this delay. Okay, so propagation delay So this is the propagation delay, TPD. Okay. Then propagation delay is also much greater than TWP. So TWP is the total duration of the clock in on condition. So this condition is also TWP. So this one we state as a TWP. So if the clock pulse is greater than the TPD and the clock on time is also less than, if this condition is satisfied, there won't be any RAS condition. Okay, so here there will be no RAS condition. If this condition is not satisfied, then there will be RAS condition. The thing is that T clock need to be greater, so that is happening here, so that is fine here. But if you see, the TPD need to be within the T clock, and the T on time, that if you see, the T on time need to be very smaller. So if we take the condition where the T on time is like this, so if it is happen like this, so if this is a clock pulse, then what will happen? Only whenever there is a change, there will be only one output change. So this condition can be avoided. So this is TPW. Okay, the thing is that the TPW is the main thing. So the TPW need to be much smaller. So when the TPW duration is very small, means this can also be there is a pulse width. So when the pulse width is very small, then we can avoid the RAS condition. So this is one key terminology. So many time the questions was asked in the gate and also some important things as. So in order to avoid the RAS condition, what will be the condition is that the T clock need to be much greater than the propagation delay. Propagation delay need to be much greater than the pulse width. So this is what the things is that we can do. So the RAS condition can also be avoided by using edge triggered JK flip flops. So whenever there is an transition in the edge, there will be this can also be avoided. So because whenever there is a change in this one, only this is getting triggered, right? So when we use a edge triggered ring, then only at the edge of transition, here only the output will change. In the rest of things, is the output won't change. So that is one thing. So what are the things we can do is that, so first thing is that the T clock need to be much greater than TPD. TPD need to be much greater than TW, that is a pulse width. Second thing is that edge triggered flip flop. Second is that edge triggered JK flip flop. Okay. So third thing, there is one more thing, that is a master slave flip flop. So with the master slave also we can avoid these kind of condition. So that we can discuss next class. So stay tuned guys. So next class I will be teaching this in fabulous manner. So for here I am leaving this to you. So please watch these videos and post your doubts in the comment section so that I will be there to rectify it. I hope this is very understood for you guys. The RAS conditions are a very important term, and JK flip flop we have avoided all the disadvantages that are present in the SR flip flop. Thank you guys. Stay tuned.